Let's take a look at a lab assignment problem from section 2.6. It says here to find the horizontal and vertical asymptotes of the curve, and this is our function right here. And so our first step is we're going to look for the vertical asymptotes. Seems to be a little bit easier. And so we basically look for when the denominator is 0. When the denominator is equal to 0, we have the whole expression is going to go off to infinity. So as long as the numerator is not 0 at the same time, those are going to be our vertical asymptotes. So we're going to let the denominator equal to 0. We have this denominator, which is a second degree polynomial. If we're lucky, it's factorable, and I think we're lucky. We got 6x plus 1 times x minus, looks like the only thing that would make this work is if this was equal to 8. And then so if that's the case, then our solution is going to be x equals to positive 8 and x equals negative. And then if I solve for this thing set equal to 0, I would bring the 1 over to the other side. That would be a negative 1 divided by 6. So I think this is going to be negative 1 over 6. And then our next term is going to be positive 8. So those are going to be the places where we will have vertical asymptotes. Step 2, we evaluate when the numerator. Now we evaluate the numerator and check to make sure if it's also equal to 0. So 1/6 into the numerator, this is the numerator. So 1/6 here would be 1 over 36 plus 10. So that's 36 over 36. That's 37 over 36. And whoops, let's try it again. 37 over 36. And when we put 8 in, we're going to get 8 squared, which is 64, plus 10. That's going to be 74. And the whole point is that it's not equal to 0. We conclude that these things are, in fact, vertical asymptotes. Oops, let's try that again. That would be, we're putting a 1 over 6 here. That would be 1 over 36 plus 10. So that's 360 plus 1. So let's say 361. All right, that's better. Remember that the point isn't to get this exact number. The point is to say that this is not equal to 0, and therefore we can conclude that we do have vertical asymptotes. And we do, so let's move on. To find horizontal asymptotes, we look at the limit as x approaches infinity in the positive, and infinity in the right, and then negative infinity on the left. So the idea is we're going to play some limit laws. One of the tricks for limit laws when we have polynomials is to take the highest power of power function in the numerator and denominator and factor it out or divide it out. So we have x squared. We'll multiply x squared by the top and the bottom. And when we multiply the top by x squared, we're going to get 1, x squared over x squared. And then we're going to get 10 over x squared. And so they want us to do this in the bottom. Let's divide everything by x squared. So the first term is going to be 6x squared divided by x squared, which is just 6. And then we have minus 47x divided by x squared. So that would leave us with an x in the denominator. And then we have 8 divided by x squared. So that would leave us with x squared in the denominator. And then I think that's it. By breaking up the polynomials this way, or by dividing it out, what we could do is we could take the limit as x approaches 0. So, or x approaches infinity, sorry. When x goes to infinity, then 1 over infinity is going to go to 0, and same thing with infinity squared, which is infinity, and that's also going to go to 0. And so that is going to enable us to take the limit as x goes off to infinity and let these things disappear. So the 1 over 10 squared would go to 0, or 10 over x squared, sorry, will go to 0. The 6 will remain 6, the 47 over x will go to 0, and the 8 over x squared will also go to 0. And so if we have 1 divided by 6, well, that's all we're going to have is 1 divided by 6. And so therefore we can conclude that y equal to 1 divided by 6 will be your horizontal asymptote. Okay, so now that we have completed it, let's actually check using a graphing calculator or some sort of graphing program to make sure that this is accurate. Let's take out our Desmos graphing and let's type in our function. Our function was x squared. It's a rational function. X squared plus 10x. I'm going to put that fraction bar in here first, and then I'll put the plus 10. Alright, so the denominator is 6x squared minus 47x minus 8. Alright, let's take a look at the details here of the graph. We have an asymptote over here. This is really hard to see, but if you look at the x values, it's getting closer to negative 1/6. In fact, we can graph a vertical line. Let's see if we can graph a vertical line. X equal to negative 1 divided by 6. And let's see if we can change this. Looks like we got the blue graph here. It's hard to see, but it is in fact an asymptote. As we get closer and closer to negative 6, this thing goes off to positive and negative infinity. And then our other asymptote looks like it's going to be positive 8. If we look at the x values as we trace this, it's going to be positive 8. Okay, horizontal asymptote. We got the horizontal asymptote to be another small number, like 1/6. Again, it's hard to see the 1/6, but if we draw a line, y equals 1/6, we can see that this thing is getting closer and closer to it. Okay. All right, so that's a graph, and that's how our analysis relates to the actual graph. If we take a look at the graph. Okay, hope that helps.